Hello and welcome to this presentation about my heating system and energy management with solar PV. This is the agenda, a couple of information about the build, and then also about the motivation, why I did this, some infos about the measures, what did I do, then most of the presentation will be about results and findings, and then no discussion obviously here because it's a recorded session. Okay, first of all, some information about the build. So this is where I live. It's a well-insulated house in Switzerland and it's built in 2007. The condition surface heated and cooled is 193 square meters. I have a geothermal heat pump with around 100 meters of geothermal probe. Heated, as I said, through underfloor heating and cooling, and the load is around about 6 kilowatts at -7. The build has a lot of south-orientated glazing, so there's a lot of heat coming in summer, and before the renovation I did not have any cooling at all. In the beginning I had solar thermal collectors on the roof for domestic hot water. I also use a ventilation system with heat recovery system. We are 4 people and the historical energy consumption is around about 10,000 kilowatt hours a year. Why did I do this? I just wanted to learn and to have more information about what we do. Also, not just the theoretical stuff, also the practical stuff, and really get more information of how to do it and what is achievable. And I installed first inverter geothermal heat pump from Stiebel Eltron in Switzerland. It's actually in my house. It's in my basement. Integration of electric car to the system as well. This was one of the goals as well, to learn more about that. Measures, what did I do? So first thing I did for this renovation was to replace the solar thermal collectors on the garage roof. I went through a couple of stages here, so vacuum tube collectors, flat plate collectors, but in the end I just replaced them with solar PV and just replaced all the collectors on the garage roof, as you see on the pictures right bottom side. So this was the beginning. It was just 5 kilowatt peak, 5.2 kilowatt peak, and this spring I added a couple of more panels on the roof. It's just because of tax reasons. I made a couple of different installations, to be honest, because you can deduct all the costs to your tax in Switzerland. Good. Then, as you probably know, the tricky thing about new heat pumps, geothermal heat pumps, is that they are more efficient, so they pull out more energy from your geothermal probe. So I wanted to learn more about how the temperature level is before the renovation. So I measured the temperature for a couple of cold days and found out that it's actually not too bad, but for me it was bad enough to decouple the domestic hot water from the heat pump system. So now I'm doing the domestic hot water with a separate hot water heat pump. Probably was not necessary, to be honest, but for me it was a little bit on the border to do it or not to do it. See a couple of numbers here. Flow temperature, minimum flow temperature was plus 3.5 degrees C. Then I replaced the heat pump. Was just 13 years old, but okay, because I work for a heat pump manufacturer, I had access to a good new heat pump, and it's actually a little bit of a test as well, so I replaced it. So now we have a geothermal inverter heat pump in the basement with a special refrigerant, HFO refrigerant, with low global warming potential. I have no heating buffer. Controller is directly operating through outside temperature and also a couple of informations from inside, so inside room temperature sensor and humidity. The heat pump is fully connected to the cloud, to internet, so I have access remote access with app and some other software. This is the heat pump, has a capacity, so we have 5 different types of it. So it's from 4 to 15 kilowatt, different types. Modulation is around about 15 to 100% of the inverter, and all the circulation pumps are also fully modulating. This model here has integrated passive cooling, so we use the geothermal drilling as a source for cooling. So we actually take out some heat from the build in summer and put it back into the geothermal probe. That's how it works. Yes, you see a couple of numbers here. I can say the COP of the old machine was a 4.3. Now we have a 5.0. So you can expect 20% more extraction from the probe, more or less. And this is the critical thing. Some information about SCOP, which is also mentioned in the technical data sheet of heat pumps. This is actually a seasonal coefficient of performance based on measurings in the lab to certain standards. But for more convenience and more information for the end user, it's actually a weighted information, weighted in relation to some climate. We have 3 different climates that we use for this information. We have a cold climate like Helsinki, the medium climate is Strasbourg, and the warm climate is Athens. So I use the Strasbourg climate for my location here. And as you saw before, the heat pump has 5.6 SCOP. So it's related to Strasbourg climate. It's only for heating, it's not for domestic hot water. And you see a couple of informations here that are used to determine the efficiency. So this 5.6 is always calculated with a bright temperature of 0 degrees, which is actually pretty low. Okay, let's go further here. The connectivity of the heat pump is done with our ISG, Internet Service Gateway. It is the name of the device. So this device is connected between the heat pump controller and your network, your home network, and it allows to integrate the heat pump to your home network, as I said, and you also have access through internet remotely. For domestic hot water, I use a special heat pump, domestic hot water heat pump. It's a WWK 300. Has some positive side effects. First is I have a reduction of the extraction of the geothermal probe of around about 25%. So I don't put more stress on the geothermal probe. This heat pump also does some dehumidification of the basement. Excuse me. It's very easy to integrate into energy management. So here I use just a Wi-Fi relay. It's a Shelly relay, and it's actually communicating through Wi-Fi. So the energy management system just closes the contact at 500 watts solar excess, and then the heat pump switches on and goes to a higher temperature level. Next step was to integrate the electric car. So in this case, we just replaced the diesel car with a Renault Zoe, and my wife absolutely loves it. She wouldn't drive any other car. And we found out that our consumption here around town is 13 to 15 kilowatt hours per 100 kilometers. Next step was to integrate an energy management system, a software. So in this case, it's a Swiss software. It's called Solar Manager. It's sitting in your network. It's connected to your network. They use a Raspberry Pi small PC with their smart software on it. And then this device communicates to all the consumers in your network. They are, for example, the heat pump, in my case, the hot water heat pump, the charging station for the car, and also some small electrical sockets where I can switch on and off devices. some results. After 1 year of operation, I found out that the COP of this installation for heating is around about 6.9 after already deducting some measuring errors. What is really interesting, because it's an inverter machine, it runs a lot longer than an on-off machine. So it's 3,500 hours compared to 2,150. It's a lot more. The savings in energy, I measure 3 things. So I measure it on the heat pump controller, which is not super accurate, to be honest, but I also have a Shelly EM energy meter that measures the consumption of the compressor and the pumps and everything. And I found out that it's using 30% less energy than before with the old heat pump. I also got a nice confirmation from my energy supplier, where you also see those 30% in savings. Inverter heat pump means also better comfort. So the room temperature is more steady, despite what's happening outside. So if you have a lot of solar gains through your window, then the heat pump will modulate back to a lower capacity. This works really nice. As you see, the blue curve is the room temperature curve and the red one is the outside temperature curve. So it's really very precise and constant. This is what happens in the geothermal probe temperature, flow and return. So I found out that the temperature actually drops a little bit lower when it's really cold for a couple of days. So here you see it actually dropped to, what is it, 1 degree maybe in really cold period in winter. But what is really nice is the temperature delta T is kept really steady through the variable speed pumps in the heat pump. So it really does a great job here. And the other thing is it's also a high efficiency pump for the brine source, and it uses around about 25%, just 25% of the old energy. So you save 75% energy here just in pump energy. What you see here, I probably don't see the blue thing. So the blue means that's the flow temperature from the geothermal probe. It's just the lower part of the curve. So you see we start in winter with maybe beginning of winter maybe with 10 degrees, and then it goes a little bit back and back and back. And middle of winter or end of winter, it's like 4 degrees C in the geothermal probe flow temperatures. So still a lot higher than we indicate on the data sheet. It's just 0 degrees on the data sheet. So the efficiency is a lot better than on the data sheet. You also see the modulating of the heat pump. So we start here in end of September, beginning of October. It's just running on the lowest RPMs, the inverter, and then it starts to ramp up and down until end of February, and then it's just again the lowest capacity setting. This couple of days here in February, like 5 days in February, was the design conditions. So we designed systems for this one, and it was like -8 degrees. The rest is just part loads. Energy management with the hydronic heat pump is possible because it's very easy to do. Software is just activating a checkbox in the controller, and then the heat pump does energy management. So what I do in my case, I measure room temperature, and if the solar PV system says I have excess power, then the room temperature is put up a couple of degrees, like 1 or 2 degrees up. And then the heat pump switches on, it runs with solar energy, PV energy. So you see here, typically this works quite nicely in shoulder season, not in typical cold winter, but in shoulder season it works quite nicely. So here you see a week in October where I actually had 5 times the situation where the heat pump was running in energy management. I use the floor for storage. So in my case, 193 square meters. When I increase the floor temperature for 1 degree, I can store around about 10 kilowatt hours of energy. Cooling is also interesting here. In this case, you see what's happening with floor cooling. What happens when I just put some colder water through the floor? It actually works quite nicely. I have good confirmation from my wife. She likes it really a lot, this type of cooling. It's a mild form of cooling. So you see here a week in September, and it's a warm week in September. The red graph shows the temperature. So it goes up and up and up and up from 20 degrees to 28 degrees. And then at a certain level, the inside temperature goes up to a threshold where the heat pump starts the passive cooling. So here you see the blue graph here indicating the rise of the inside temperature. And here at this point where the green boxes here start, active cooling is started. And you also see the blue curves go lower, they go back. So cooling is doing something. So we would say normally you achieve 2 to 3 degrees lower room temperature with floor cooling. It's more or less for free because what's running then is just 2 pumps and the controller, so it's around about 100 watts that you use for cooling. Hot water with the domestic hot water heat pumps. Heat pump here, in this case, I can say I use around about 3 to 4 kilowatt hours a day for hot water. It's 4 people plus the washing machine. So I also connected the washing machine to the hot water tank. The heat pump cools down the room to 3 to 4 Kelvin, so it's a little bit colder when it's operating. The hand calculated COP, I'm not measuring here, I'm just measuring electrical consumption, but not flow and energy on hot water. But it has an indicator on the controller how much energy is in the tank. So I have like a hand calculated value, and it's between 3 and 3.5, the COP. EV charging. So that was the next thing. I added one of these nice boxes from Norway, Easy Home is it called. And the nice thing here, I can integrate it into the energy management system. And these boxes here, they can switch between 1-phase and 3-phase. And they also can adapt the amps to the actual excess power that you have from solar. So that works really nicely. But the car has to be home. So if the car is not home, it doesn't make any sense. So here you see a nice day in May. It was, so it's actually still with the small PV system, 5.2 kilowatts. But you see here in the morning, it's like the coffee machine switching on here, and then at 8 o'clock roughly the hot water heat pump starts because it has excess power from solar. But then it goes a little bit further, and at a certain level the car charger switches on, and then it adjusts the power of the car charging. Works really nicely. Some numbers here in autarky and self-consumption. So I had to calculate them, to be honest, because I installed the additional 2 kilowatts in May. So I had to use some numbers here and calculate it. So I expect to have a little bit just below 50% of autarky, and self-consumption is around about 70%. I will have these 11,000 kilowatt hours in total consumption. So for this house and 2 EVs. Here you see what's happening in winter. So winter is a bit frustrating, to be honest. This is March with no snow on the panels. Self-consumption is very high because it's a smaller system. Autarky is just 35%. Typical summer month like August, also very nice, self-consumption 60%, and autarky is around about 70%. Remember, it's 2 electric cars and everything is electric, hot water, everything. You see here what's happening with the energy management system. So all the consumption is laid into the day period where you have a lot of solar. An overview of the consumption, so 7.2 kilowatt peak install. Total consumption for my house is 11,000 kilowatt hours. I use around about 2,000 kilowatt hours for heating and cooling, and also the circulation pumps. Hot water is 1,200 kilowatt hours. So it's really like 2/3 and 1/3 heating and hot water. Also run a ventilation system, but it's not really using a lot of energy. Coffee machine uses a lot of energy, I have to say. Nice one is here, laundry, because it's connected to the heat pump, hot water heat pump. It's really just doing the motor of the heat of the washing machine. No heated is used here, so it's really just 60 watt kilowatt hours for laundry. Dishwasher and 2 EVs are the biggest part of the consumption, to be honest. It's like 3,000 kilowatt hours. Good, that's it. So if you have questions, if you want to do something like this as well in your house, just give me a call or write me a short email. I work for Stiebel Eltron. It's a heat pump manufacturer, and we also do integration of energy management systems. So if you have solar PV and you want to switch to a heat pump and you want to get most of your solar PV system, please talk to us. We can guide you through the process of realizing or doing an installation like this as well. My name is Oliver Joss. Thank you for your time and see you next time.